Coming to solubility of a gas in liquid. Solid in liquid is over, now gas in liquid. Almost all gases are soluble in water, but to different extent. The amount of gas which can be dissolved in unit volume of a liquid to form a saturated solution of that gas at a given condition of temperature and pressure is known as its solubility. Factors which affect the solubility of gas in liquid. Number one, nature of gas, that is together we are taking solute and solvents, nature. The solubility of different gases in the same solvent varies. In the same manner we saw that in solid. For example, O2 and 2 are non-polar, so they are less soluble in water. But when we take polar gases such as HCl, SO2, they are more soluble in water. What about NH3 and CO2? Its polarity is very less and it is non-polar almost. Still it is more soluble in water because these two can react with water. I can show you here it. See how ammonia react with water. It gives ammonium ion and hydroxide ion. Similarly, CO2 in water gives H2CO3. Therefore, these substances are soluble in water. This is how the nature of solute and solvent affect the solubility. Effect of temperature. Effect of temperature on what? Solubility of gas in liquid. Definitely, solubility of a gas decreases with increase in temperature. We have to associate it with Le Chatelier's principle. Let us see. First, understand this thing. Suppose we are taking oxygen dissolved in water at 273 Kelvin. In this case, we have more particles in here of oxygen. Let us start heating this solution. When we heat and make the temperature reach 298 Kelvin, we see that amount of oxygen is less because more and more oxygen is escaping from the system. So less oxygen here, more oxygen here. Experiment suggests that oxygen's amount at 298 Kelvin in the solution, same solution, is just half as they were present in 273 Kelvin in the system. So why so? It is actually when the oxygen gas is dissolved in water, their particles are coming closer. That means they are becoming more systematic. Randomness decreases. Del S negative. When del S is negative in any system, del H is also negative. It means heat is released. Process is exothermic. And according to Le Chatelier principle, in such a system wherein the gas is in liquid, which achieves equilibrium by making a solution, and in the process we have heat. On increasing the temperature, this heat effect is experienced here. So to undo the effect, it moves in this direction. It means our del S is now becoming more positive. More positive means particle will come out. That is why increase in temperature does not favor solubility of gas in solid. Effect of pressure. That is how solubility of a gas is affected by increase or decrease of pressure. This can be explained by this experiment. Here we have certain pressure on the gas over the liquid surface, but now we are increasing the pressure. Can you see? We increase the pressure here. So on increasing the pressure, what happens? Consider this system is already in equilibrium. At that time we are increasing the pressure. Now what happens? More number of gas particle per unit volume of the solution will be collected, and they will strike more frequently with the liquid surface and try to enter into the solution. So they can enter more gas particle can enter into the solution. Thus a new equilibrium will be achieved. So naturally we see that in this case more gas particle per unit volume will be present. So increase in pressure of the gas will make it more soluble in the solution. This is our qualitative approach, but Henry has given a quantitative approach. Let us see just it in a definition form. According to him, at a constant temperature, see the temperature we have to keep constant. At that time, the solubility of a gas in the given amount of a solvent is directly proportional to the partial pressure of the gas which is exerted on the liquid surface, or which is present, that pressure which is present above the surface of liquid or on the solution.